Hello everyone, I am Rakshita Jayaraikar. My teammates are Pavitra, Rakshita and Chetan Kumar. Our topic is about looping and mathematical operations. Mathematical operations on small data sets. Our first question is to find the factorial of a number. The scenario is number n, which is stored at 60h, and task is to find the factorial and store at 61h. Let us execute our code. Please. The result n factorial will be stored at address 61 after the program runs, and the program starts at the memory address 000h. Move the value stored at memory location 60h into the accumulator, and then copy n from a register R0. Now R0 will act as a loop counter, and initialize a to 1. This will hold the running result factorial value, and compare R0 with 0. If R0 is not equal to 0, then go to the label loop. If R0 is equal to 0, skip to store. The factorial of 0 is 1. And move B to R0, copy R0 into register B, and multiply A and B, store the result in A and B. Since the factorial grows fast, this works only for small numbers like a small n value, and decrease R0 by 1 and jump back to the loop if R0 is not equal to 0. This repeats the multiplication until R0 becomes 0. Then we get the final result as the factorial value, and which is stored in the memory location 61h. And we can see this is the output.
And second question is greatest common divisor, and the scenario is two numbers stored at 62h and 63h, and the task is given that find GCD using subtraction method and store at 64. And this is the code ORG000H. This means start the program from the beginning. Move A, 62H means first number is in box 62. Move B, 63 means second number is in box 63. Compare C, J and E, A, B. Note here, if A and B are equal, it means we found the GCD. If they are not equal, go to the note here to fix it. SJMP, store underscore GCD. When both are equal, that number is the GCD. Note here, JNC subtract underscore A. This check which number is bigger. If A greater than B means it jumps to subtract underscore A. If B greater than A, it stays here and does the subtraction the other way. And next, move R0, A means temporarily store A. Next, move A, B means move A to B. Subtract A, R0 means A equal to A minus R0 into B minus A. Move B, A means store result back in B. Move A, R0 means restore A. SJMP compare, jump back to compare. Subtract underscore A, sub A, B means A equal to A minus B. SJMP compare means jump back to compare. Store underscore GCD means move 64H, A. This means store the GCD in A to location 64H, and finally the program ends, and this is the output.
This is the third question. Square of a number scenario, number stored at 65H. Find the square using repeated addition and stored at 66H. This is the code of the third question, where the ORG 0 A, 65H, the number we want to square is kept in memory location 65H. We move that number into a our calculator box. Then move R0 comma A means copy the number from A into R0. R0 will help us count how many times we will add the number. And next one is move a comma hash 00h. This means set a to 0. This will hold our final answer. And next one is a loop square. This marks this start of our loop. And next one is a add a comma 65h. This means add the number to a, and each time we are adding the number to itself. And next one is a dj into r0 comma loop square. It means decrease r0 by each time, and if r0 is not at 0, then go back to the loop square again. This means repeat the addition as so many times as the number itself. And next one is a move 66h comma a. After the loop finishes, the final answer is in the a. We store it memory in 66h, and this is end the program. Here the program is finished, and it is the output of our program.
I'm explaining the fourth question, sum of squares of n natural numbers. Here the code, the program starts from 103, 0 into 67. For each number down to 1, it computes the square using repeated addition. It adds every square to a running total. When it finishes, it is saved the final answer at memory location 68 heads. And our program tests the sum of squares of number 103 down to 1, but it stores the running total in an 8-bit register R1. So the result is incorrect because of overflow. There the output of this program.